All right, hello everyone. Here are the solutions to the quiz that you wrote Thursday morning. Number one asks you to simplify this expression completely, and it's actually three rational expressions. What we're going to do is rewrite this to begin with. We're not going to worry about factoring just yet. We're going to rewrite this. But instead of dividing by that second rational expression, we're going to multiply by the reciprocal. And then we're multiplying by the third rational expression, so I'm just going to rewrite that. Just take a second to double check to make sure that I've written everything correctly. And it looks good. I've told you before that when you have to multiply by the reciprocal, at some point as well, you're going to have to factor. It doesn't really matter. I suppose you could have factored everything first and then multiplied by the reciprocal, or multiply by the reciprocal first, which is what I did, and then factor. I would just caution you again not to do two things at once. So now we can factor. The first trinomial is going to be factored using trial and error, along with a bit of common sense. It factors into 2x minus 1 multiplied by x plus 3. It's over. The denominator has a common factor of x, which leaves me 3 minus x. When we're multiplying rational expressions, which is what we're doing right now, we can just continue to multiply entirely across the top and entirely across the bottom. So I also have an x squared minus 9, which is x plus 3, x minus 3. On the bottom of that, I have another trinomial, which I'm going to factor using trial and error, again with a little bit of common sense. I need 9x for the inner term. Well, if I put a 5 here, then the product of the 5 and the 2x would give 10x. If I make that 5 a positive, I'll get positive 10x, and the 1 is negative 1x, which gives me 9x. The other two trinomials do not require trial and error because the coefficient of each of these is 1. I simply need to look for two numbers that multiply to give the constant term, in this case of negative 2, and add to give the middle term coefficient of negative 1. So that factors into x minus 2x plus 1, and the denominator, the same type of factoring. What two numbers multiply to give negative 6 and add to give positive 1 would be positive 3 and negative 2. Everything is factored now. Now all you have to do is cancel, and there is a bit of a wrinkle in this question. First of all, the 2x minus 1's cancel. We have an x plus 3 on the top and the bottom that cancels. We have an x minus 2 on the top and the bottom that cancels. And then we also have the following two terms. We have on the denominator 3 minus x, and in the numerator x minus 3. And I'm going to go through this one more time with you. When you have x minus 3 over 3 minus x, you can factor a negative 1 out of each term in the denominator. And if I factor negative 1 out of positive 3, it becomes negative 3. And when I factor negative 1 out of negative x, it becomes positive x, which means when I factor negative 1 out of 3 minus x, I'm left with x minus 3, which cancels. And we're left with this factor of negative 1. And this is why I've told you in class that we have this kind of rule, this added rule that says when you cancel two factors that look like that are negatives of each other, then you have to put a negative 1 as a factor someplace in your answer. What you choose to do with that negative 1, it really doesn't matter. Here's the answer to question 1. We have to have an x plus 3 in the numerator. We have to have an x plus 1 in the numerator. We need an x in the denominator, and we need an x plus 5 in the denominator. And we need a negative 1 someplace. Most of you just put it right in front of the x. You could put it in front of the numerator, or you could put it in front of the entire expression. In either case, that's the answer. Look at question 2, simplify completely. So we're subtracting rational expressions, which means we need to determine the lowest common denominator. We need to determine a denominator that we can convert both of these denominators to. But you cannot identify a lowest common denominator in most cases, and this is one of them, without factoring everything completely. So b squared plus 5b plus 6 factors into b plus 3, b plus 2, because 3 times 2 gives you the 6, and 3 plus 2 gives you the 5. Leave a bit of air, minus b minus 6 over, while the bottom of this second fraction factors into b plus 2, b plus 4. The lowest common denominator must contain both of these denominators. So the lowest common denominator has to contain a b plus 2 and a b plus 3. It has to. The lowest common denominator as well needs to contain these two factors. Now, what we've got written so far at the top of the screen, what we have written so far includes b plus 2. So both of these are represented in the common denominator. This is represented in the common denominator, but we need to represent the b plus 4 as well. So if we write b plus 4, we've nailed it. What does this mean? It means that I need to multiply the top and the bottom of each of these fractions by something to get the new denominator. Well, if I want to get b plus 2, b plus 3, b plus 4, and the first fraction already has b plus 3 and b plus 2 in the denominator, then I need to multiply the top and the bottom by b plus 4. The second fraction already has a b plus 2 and a b plus 4. It's missing the b plus 3, so I have to multiply the top and the bottom by b plus 3. And now I can put these together. So now I have the entire thing over b plus 2, b plus 3, b plus 4. The order in which you write these three factors doesn't matter at all. I also have 2b times b plus 4 minus b minus 6 times b plus 3. And some of you simplified the b minus 6 times the b plus 3 up here, and that's fine. Some of you as well simplified the 2b times the b plus 4 up here. That's fine as well. I prefer just to do it in the next step. So I'm going to have to multiply 2b by b, 2b by 4, and then we're going to have to, of course, apply our FOIL rule for multiplying these two binomials. So when I multiply 2b times b, I get 2b squared, plus 2b times 4 is 8b, and then I have minus. First will be b squared, outer will be 3b, inner is negative 6b, and last is negative 18. This is over b plus 2, b plus 3, and b plus 4. And if you look at what I have written right now, it's wrong, and I think there were 7 of you in the entire class that made this mistake. What's wrong with it is we're subtracting the product of b minus 6 times b plus 3. So this set of brackets is not an option. That set is necessary. Okay, let's continue. Now I have 2b squared plus 8b. I have minus b squared. This is negative 3b, and I'm subtracting negative 3b, so that gives me positive 3b. And then I'm also subtracting negative 18, which gives me 18, over our denominator. On the top, we have b squared that's negative, and we have a positive 2b squared. So 2b squared minus b squared is b squared. We have 8b plus 3b, which is 11b, and then we have plus 18 over our denominator. We're almost there. The numerator factors because there are two numbers that multiply to give 18 and add to give 11. They are 2 and 9. So the numerator factors into b plus 2, b plus 9, and on the bottom we have a factor of b plus 2, b plus 3, b plus 4. The b plus 2's can now cancel. And this is your final answer, b plus 9 over b plus 3 multiplied by b plus 4. I hope that's helpful. These are the kinds of questions that you would expect to see on your exam, which will happen next week, I believe on Friday of next week. So in the meantime, have a wonderful long weekend, and I look forward to seeing everybody on Tuesday. Take care.